10.1, number 21, says the frustum of a cone, the line segment joining the points 0, 1, and 2, 2 is revolved around the x-axis to generate a frustum of a cone. Alright, so frustum of cones, like if you imagine those things that people yell into to amplify their voices, hold it up to their mouth. It's kind of like, well, a cone with a top missing, so kind of like a cone used in soccer. Anyways, so if you have 0, 1, and 2, 2, 0, 1, and 2, 2, we're supposed to find the parameterization for the line segment joining the two. Okay, so if we go from 0, 1 to 2, 2, the parameterization, the easiest one we could do, well, it's x equals and y equals. We start our x at 0. That's our first x. And then how do I go from 0, 1 to 2, 2? In the x direction, we've gone 2 units to the right. So it's 2t. And then y, we start at 1. And I go from 1 to 2 in the y direction. So I'm going up 1t. Now this is just one parameterization of the line segment. That's saying that it's going to take 1 second for it to go from here to here. Notice if I plug in 0 for my x, I get 0. 0 for my y, I get 1. So I'm starting at 0, 1. That's my initial point. My terminal point is when I plug in 1. 1 into x, I get 2. 1 into y, I get 2. So it does go all the way to 2, 2. So initial x, what you're going up by, is slope. Initial y, what you're going up by. Alright, so that's part A. Part B, find the surface area of the frustum using the parametric equations in A. Okay, so we got to revolve it around the x-axis. So we're going to find the surface area of that. Okay, so we've got our surface area equation for parametric equations. It'd be the integral. In this case, we're integrating from 0 to 1 for t. So from 0 to 1, and it's 2 pi times the y, which is just 1 plus t, and then times the square root of dx dt, which is 2 squared, plus dy dt, which is 1 squared dt. Okay, that will get us our surface area. Alright, so square root of 4 plus 1 is 5. Square root of 5, that's just a constant. So in a 2 pi, so I have a 2 pi square root of 5 out front. Now I'm integrating from 0 to 1, 1 plus t dt. So antiderivative is t plus 1/2 t squared from 0 to 1. Gives us 1 plus 1/2 minus 0. So I get 3/2. And still times the 2 pi square root of 5. So 2 pi square root of 5 times 3/2 gives us 3 pi square root of 5 to be units squared for our surface area. Part C, find the lateral surface area using the geometry formula. Area is equal to pi times r1 plus r2 times our slant height. Alright, so that's using the geometric formula. So pi times, we have 2 radii. We got r1, which is 1, and then r2, which is 2. So 1 plus 2 times our slant height. Slant height is this distance right here. So let's see, I've got a right triangle. So there's my right triangle. So this is 1 and this is 2. So this would be the square root of 1 to square root of 5. So my slant height is the square root of 5. So pi times 3 times square root of 5 is 3 pi square root of 5. So using our geometry, we end up getting the same answer as using our calculus.